Hi kids, it's Mr. Z, and today we're going to learn about compound inequalities. So in compound inequalities, we're going to have two inequalities, and they are going to be connected either with the word and or the word or. At the top of the page here, we can see we have two inequalities, and they are connected by the word and. So it says x is greater than 2 and x is less than 6. Well, they made a note here that if it's the word and, we're talking about an intersection. And for an intersection, we're talking about an overlap, or I'm going to call it a double shaded region. So our intersection is going to be where the number line is double shaded. Also up here at the top, we have the word or. We have an inequality connected with the word or. So this is x is less than 2 or x is greater than 6. So for a union, what we want to look for is anywhere that's shaded. So again, for the union, we're going to be looking on the number line for any part of the number line that it ends up being shaded. Let's look carefully at this statement right here. It says 2 is less than x is less than 6. We'll talk about what this means later on, but what I want you to realize is that this is really two inequalities. So the first inequality we have here would be this one on the left. That one says 2 is less than x. Well, we've talked many times about how we rewrite these inequalities with a variable on the left. And in effect, I'm just going to read this kind of backwards. I'm going to read this from right to left. It would say x is greater than 2. Well, that is exactly what we have right here. That's the same inequality. And then the other inequality that we have is here on the right that I'm circling in green. That says x is less than 6, and I think you can see that that's the same as this one. All right, so when you see this written, when you see this statement, 2 is less than x is less than 6, it's really a compound inequality that's connected by the word and. All right, there's two inequalities there that are connected by the word and. Let's graph these two inequalities. The first one we have here is x is greater than 2. So let's draw that. So let's put 2 on our number line. And it does not have the equal to bar, so we are going to make an open circle, and we are going to shade to the right. Now let's graph our other inequality, this one right here, x is less than 6. Let's graph that one in green on the same number line. So let's put 6 on here, right here in green. That does not have the equal to bar on that inequality either, so that's going to be an open circle at 6. And this one is shaded, well, it's all the real numbers x less than 6. So we're going to shade to the left of 6. Since these two inequalities were connected by the word and, we know that that's an intersection, and we're looking for the double shaded part. So what we're looking for in this one then is we're looking for the part, not for the part that's just red or the part that's just green, we're looking for the part where it overlaps. We're looking for the double shaded part that's both red and green. Well, I think you can see where this bottom statement comes from now. So it's all the numbers in between. So this statement right here, 2 is less than x is less than 6, that's a between this statement. The double shaded part here, the intersection, is all the numbers in between 2 and 6, not including 2 and 6 because of the open circle. So how we write that between this statement, I'm going to rewrite it for you, is we know we want the real numbers x that are in between. So we put x in between the 2 and the 6, and then it'll always be a less than symbol and a less than symbol, or it could be less than or equal to. All right, so there's that same statement that was written above. That's what our number line is showing. It's the overlap is all the real numbers x that are in between 2 and 6. Now on the right, let's graph these two inequalities that are connected by the word or. So I'm going to do the same thing. So the one on the left, I am going to circle that one in red. Let's graph that one. So we would have, let's put 2 right here. We don't have an equal to bar, so it's going to be an open circle. And it's the x is less than 2, so it would be shaded to the left. Then let's graph the other inequality in green. So let's put 6 right here. Again, that's an open circle because we don't have the equal to bar, and that's a x is greater than 6, so that's all the numbers to the right of 6. All right, well then our answer for this one is, since it's a or a union, it's anywhere that is shaded. Well, anywhere that is shaded here is just the statement that we have written right here. So this number line is shaded where x is less than 2 or where x is greater than 6. Well, that's kind of our background information. Let's go on and solve these example problems, and I think that you'll see how this all fits together. Let's solve the compound inequality for number 1. So what I want you to realize here is there's 2 inequalities. Again, I have one on the left here. This one is in red. And I have a second inequality here. This one will be in green. That is this one. And really, they are connected with the word and. So let me write that out for you. So here's our 2 inequalities. I have the red one, and I also have the green one, and they are connected by the word and. So let's go ahead and solve each of these. So on the left here, I've got to get x by itself, so I'm going to subtract 1 on both sides. On the left-hand side, I have -5, take away 1 more, would be -6. Put in my inequality symbol. On the right, the 1 and -1, they cancel out and make 0, so all I have is x on the right-hand side. And then again, I don't like to leave these where the variable is on the right-hand side, so let's rewrite it with the x on the left-hand side and the -6 on the right-hand side. And then remembering that I have to keep this pointing the same way when I rewrite it. So right now it's pointing towards the -6, so it will still be pointing towards the -6. And then let's go over and solve the other one. So on that one, I'm also going to subtract 1 on both sides. The ones are going to cancel on the left-hand side. I get x is less than. On the right-hand side, I have 2 minus 1. That is 1. And then don't forget that these are really still connected with the word and. All right, so let's graph each of these. So I'm going to graph the left one in red. So in red for that one, I'm going to put -6 on my number line. And then I do not have the equal to bar, so I'm going to make an open circle. And this one are the x's greater than -6, so I'm going to shade it to the right. And then I'm going to graph my second inequality here. I'm going to graph it in green. So if I do this one in green, again, I'm not going to do this to scale on the number line at this point, okay? Just make sure that the -6 is to the left and the 1 is to the right on your number line, okay? The numbers have to be in order, left to right, but they do not have to be to scale. So I'm just going to put my 1 here in green right here. That's my 1. And again, I don't have an equal to bar, so that's an open circle. And these are the x's less than 1, so I'm going to shade to the left. And now you remember now, my solutions for this compound inequality, it's really, again, 2 inequalities that are connected by the word and. Well, and is the intersection, so I'm looking for the overlap. And I told you that that would be the double shaded region in here, okay? It's where it's double shaded. It has to be both red and green. Those are going to be my solutions to my compound inequality. So then how do I write my final answer? Well, I've got to describe this region that's shaded in both red and green. So the way I do that is I have -6 on the left, I have 1 on the right, and I want all the x's that are in between those two numbers. So I'm going to put x in between, and I'm going to make a less than and a less than. And there you go. That's going to be your solution. That is the overlap. That's the red and green part. That says -6 is less than x is less than 1. That means all the solutions for this compound inequality, the original inequality, are all the numbers between -6 and 2, I'm sorry, -6 and 1, all the numbers in between there, not including the -6 and the 1 because of the open circles. Now I think above it says don't forget to check your answers. So to check your answers, what you'd have to do is you'd have to pick a number in the double shaded region on your number line. So you want to pick an x value that's between -6 and 1. So to do the check, maybe an easy one to pick, easy number between -6 and 1 would be 0. So let's do a check with x equals 0. So let's check our answer. So we're going to do our check right here. And we're going to do check our answer. We're going to say let x equals 0. 0 is definitely in between -6 and +1. And it is definitely in this double shaded region. So what we have to do to do the check is we have to substitute x equals 0 into the original inequality. So if we look at our original inequality, that was -5 is less than x plus 1 is less than 2. And then if this checks correctly, if we did the problem correctly, that should be a true statement when we replace x with 0. So just to save a little room here, I'm going to put in my 0 for x right here. So I'm going to replace that x with 0. Well, now what I have is -5 is less than, well, then I go ahead and add this right here. Again, my x right here is 0. That's what I substituted in for x. So 0 plus 1, that's 1. And then I bring down my other inequality as less than 2. Well, is that statement true? If you read that statement, it says -5 is less than 1 is less than 2. So this is true right here. -5 is less than 1, and also 1 is less than 2. So that's true. So since that is true, we know that our answer is checks. All right, our answer is good. Well, let's move on to number 2. Number 2 is a compound inequality where we have two inequalities connected by the word or. Well, we already have two separate inequalities here, so let's just go ahead and solve them both. All right, so in the inequality on the left, we are going to get t by itself, so we're going to subtract 8 on the left side and subtract 8 on the right side. The 8's cancel on the left-hand side and make 0, so all we have left on the left-hand side is a positive t is greater than or equal to. And on the right side, we have 7 minus 8. Well, 7 take away 8 would be a -1. And then let's solve the inequality on the right. So for that one, we're going to subtract 8 on both sides again because we're trying to get the t by itself. The 8's cancel out, and on the left-hand side, we have a positive t is less than 2, take away 8 is -6. Now, you must remember that these two inequalities are connected with the word or, and the word or is the union. So we're going to be looking for anywhere that's shaded. So let's graph these. So the inequality on the left I will do in red. So this one I'm going to do in red. And I'm going to put -1 on my number line. And I do have the equal to bar this time, so I have to make the solid circle. And I need to be greater than or equal to -1, so I am going to shade to the right. The other inequality, I'm going to do this one in green. So I'm going to do this one right here. That one says t is less than -6. Well, again, I need to make sure I put my numbers -1 and -6 in the correct order on the number line. So -6 would definitely be to the left of -1. And this time on this one, I do not have the equal to bar, so I'm going to use an open circle. And I am going to shade this one. It's the t's less than -6, so I'm going to shade this one to the left. Now the answers to my union problem, they could be a solution to the first inequality, or a solution to the second inequality, or they could be a solution that works in both of them at the same time. So that's why it's anywhere that's shaded. Well, if you look at what's shaded, it's exactly what I've written right here. That's what's shaded. It's shaded to the left of -6, which is the green one, and it's shaded, well, with a solid dot, it's shaded to the right of -1, which is this red one right here, all right? So that's how we describe anywhere that's shaded. We really have the answer here already. I guess I could rewrite it if you want me to. So our final answer for this one is t can be greater than or equal to -1, or t can be less than -6. So that actually is my solution to this one. Any of those t values, anywhere that the number line is shaded in. Now let's look at number 3, which is really the same type of problem we had in number 1. But I'm going to show you a little bit quicker way, a little more of an alternative way to do this one. We still have two inequalities here. In red, we have this inequality here on the left. And in green, we have this inequality here on the right. And we're really solving both of those inequalities with the word "and" in between them. So then we're looking for the intersection or the overlap or double shaded region on our number line. But I'm going to show you a shortcut for doing this. So we can solve both of these inequalities in number 3 at the same time. They're really connected by the word "and", but we're just going to go ahead and solve this with this alternative method that I'll show you. So let me erase what I circled here. Really just keep in mind that we're really solving two inequalities that are connected with the word "and". All right, so how we're going to do this is we're going to solve them both at the same time. So what we're going to do is we want to get this x term right here, this 3x term, we want to get that by itself. So what we would do is we would add 1 because we want to get 3x by itself. So I am going to add 1. Well, then when I'm solving the inequality on the left, the one that I had circled in red, that means I would have to add 1 to the 8. But then if I was solving the inequality on the right that I had circled in green, I would have to add 1 to the 11. Well, doing that, now on the far left here, I have 9 is less than the -1 and +1, the -1 and +1, they cancel out and make 0. So all I have left in the middle now is 3x, and I bring down my other inequality, which is a less than or equal to, and on the far right there, I have 11 plus 1 is 12. Well, if I wanted to get x by itself, well, I'd have to get rid of this 3 right here. Well, the opposite of multiplying x by 3 would be to divide by 3. So in the inequality on the left, I would divide both sides by 3. But then in the inequality that I have on the right, I would divide both sides by 3 also. So it would look like that. Well, then what I have on the far left is 3 is less than. The 3's in the middle cancel out and make a 1. So I just have x or 1x in the middle. And then I bring down my other inequality, which is a less than or equal to. And on the far right, I have 12 divided by 3 is 4. So really, what I've done is I have my solution right now. If you look back at what we did in example 1, let's go up there and take a look. So if we go back up and look at what we did in example 1, we got a solution that looked like this right here, right? The solution was all the x's that were between -6 and 1, not including the -6 or the 1. Well, now look at the solution we have here when we did this all at once. So this shortcut got us to this point right away. Now our solutions are all the x's, all the real numbers x that are between 3 and 4. Not including the 3 because we don't have the equal to bar, but we do have the equal to bar here, so the 4 would be part of our solution. So the solution is all the numbers between 3 and 4, not including the 3, but yes, you would include 4 as part of your solution. Then all you need to do is graph that. So if we want to graph this, what we could do now is we could just put 3 on our number line, and then we will put 4 on our number line. Again, the numbers have to be in order on the number line, left to right. And then we don't have the equal to bar on this inequality, so we would have the open circle at 3. So there's our open circle at 3. And then we do have our equal to bar on this inequality, so we need the solid circle at 4. So we draw the solid circle at 4. And then again, our solution is all the x's, all the real numbers x that are between 3 and 4. So we just shade in between 3 and 4. So there you have it. So there's a shorter way to do number 3. I mean, if you want to do it like I did number 1, that's fine, but I thought I would show you both methods. In number 4, we already have two inequalities. They're connected with the word or. So since they're already separate inequalities, let's just go ahead and solve them both. So on the inequality on the left, the first thing I would do would be divide both sides by 4. And the 4's would cancel out on the left, and I get x is less than or equal to 20 divided by 4 is 5. And then in the inequality on the right, I would divide both sides by 3. And then the 3's would cancel out and make a 1 on the left. So I'd have 1x on the left is greater than 21 divided by 3 is 7. But then don't forget that these are connected by the word or still. So now we're going to go ahead and graph these on our number line. So the first number we have to put on there would be 5. So let's put 5 right here. For 5, we do have the equal to bar, so we would make the solid circle. And it's the numbers less than or equal to 5, so we would shade to the left. And then on our other inequality, let's put 7 right here. That one does not have the equal to bar, so we're going to make the open dot at 7. And that's the x's that are greater than 7, so we would shade to the right. So that really is the picture of our solution right there, because remember in an or, that is the union, and that's anywhere that's shaded. So this statement that I wrote right here that I'll circle for you, that is our solution. All right, we're looking for x's that are solutions to this first inequality, or solutions that work for the second inequality, or that work for both of them at the same time. So that completes number 4. So that is our graph for number 4, and this is our solution right here. Now let's look at examples 5 and 6. And I think these two will go pretty quickly. You have to look at the graph and write the inequality. Well, I got to make a couple graphs for you here, so let me do that. So I've drawn you a couple examples, a couple graphs for number 5 and number 6. So I'll give you a second if you want to copy those graphs. Okay, so all we have to do on these last two problems is we just have to write an equality by looking at the graph. Well, I think you can see on number 5 that, again, we're looking at where it's shaded in. This would be like the double shaded part right here. It's all the numbers, all the real numbers x in between -5 and 1. So to write the inequality, we want to write x, all the real numbers x, between, so we'll put x between -5 and 1. All right? And then all we have to do in this, between this statement then, is put a less than and a less than. So right now we have all the real numbers x in this shaded region, and our x is in between -5 on the left and 1 on the right. Again, making sure that you put the numbers in order left to right on the number line. So then when you write this between this statement, you still put the number that's less on the left and the number that's larger on the right. Now the only thing we're missing here is we have an open circle at 1, so we do not need the equal to bar. But in this case, 5 is part, or -5 is part of our solution because of that solid circle. So we need to add the equal to bar to that part of the inequality. So there you go. That's the inequality based on the picture in that graph. So number 5's done. Number 6, well, number 6, there is no overlap, all right? So when there's no overlap, there's no double shaded part. So what we're going to do then is that we've got two separate inequalities there. So one of them is all the x's that are less than or to the left of -7. And then the other one is all the x's that are to the right of -2. So that would be greater than -2. And then because of the fact that they're separate, they're actually separate disjoint sets. All right, all the real numbers are here are to the left of -7. All the real numbers here are part of our solution are to the right of -2. Well, then that's going to be a union when we have two separate sets and we have this gap in between. So that means that we need to put the word or in between here. All right, and there's one more thing that I'm missing. There's the open circle at -7, so we do not need the equal to bar. But then if this was part of our shaded in solution, remember on a or an intersection, our solution is anywhere that's shaded. So then we see we have the solid dot, so -2 would be included as part of our solution. So we would have to add the equal to bar on that part of the inequality. And there you go. So that's our inequality for number 6. That wraps up section 3-6. So again, I just like to say thanks for watching, and I'll see you guys soon in class. Bye.